Alright, this video is going to be hopefully fairly short. I don't want to spend a lot of time trying to prove anything about the surface area of a sphere here, but I just want to point out how the surface area of a hemisphere works. A lot of people have mentioned in the past that they thought the hemisphere should be 2 pi r squared because they're thinking about hemi as half of a sphere. And they go in and say, well, look, half of 4 pi r squared should be 2 pi r squared, so that should be a hemisphere. And if all you cared about was this outer curved portion, and let's say you cut a basketball in half, then sure, that outer part would sort of be what you'd be looking at. But if I were to go in and have some sort of shape, some kind of dome shape that had its own base, a hemispherical shape with a circular base like this, the 2 pi r squared would just be the outside portion, the outer curve. And you'd be neglecting the base, the part that would be at the bottom of the figure. And so what I want to point out here is we would need an additional pi r squared to represent the base of that figure, to represent that circular base. So we actually end up with 2 pi r squared plus 1 pi r squared. So we have a total of 3 pi r squared for our hemisphere. Now, as far as using these surface area formulas go, these are some of the fastest problems to work through, some of the simplest ones to work through, because they just give you a radius, you plug it in, you're done. They could try to make it more difficult only in the fact that they might hand you the diameter. So just don't forget that if they give you a diameter, that the diameter is just 2 times whatever your radius is, or 2 times your r value. So to find r, just cut your diameter in half and you'll be okay. So just as a quick and easy example here, let's do the surface area of a sphere. We'll say of a sphere with a radius equal to 7. We'll just do that. So we just go in and say, okay, well, that's going to be 4 pi times 7 squared. Easy enough to go in and say this is 49 for the 7 times 4 pi. And then you can either grab a calculator or very quickly, hopefully you would see that 49 times 4, 4 times 9 is a good 36, 4 times 40 would be 160, so we get a nice 196 here to work with. And then from there, it's just a matter of going in and saying, well, this is exactly 196 pi, or, now this would be something I'd want a calculator for, if I wanted to know a decimal approximation, let's say I don't know what that number looks like, we could go ahead and figure out that this is approximately a surface area of 615.75. So either one of these would be acceptable answers depending on what they've asked you to do. Just be mindful that if you're working in something like IXL, they will expect you to use 3.14 instead of pi actually the way it is. And so notice that their answer is technically incorrect, but so is mine if you argue rounding not being accurate. So here, just be mindful again of that. If we wanted a hemisphere the same radius, so let's go ahead and just do surface area of a hemisphere with a radius equal to 7 as well. The only difference here is that we're going to end up doing 3 pi times 7 squared, and that's super simple here to do. We'll just go ahead and throw it into a calculator. I'm not going to spend all day on anything like this because I don't want to waste your time, but just throwing that out there. We can even type it in exactly the way I've written it here, and you'll see about 461.81. So just pointing out, these problems are very fast to work through, very simple. It's just a matter of knowing the formulas, knowing where to plug values in, and then just grabbing that calculator and letting it do all that work for you.